Hey, how's everyone doing? Good? You've had a good day so far? Yeah? You've used the Raspberry Pis, I think, yeah? You've written some code? Yeah? Awesome. So, hi, my name is Lorne, as Kate just said. I would like to start by telling you a little bit about myself. Here's a photo I took last summer. I was in Africa. We did some snowboarding on the sandboarding, which was pretty cool. So I'm Canadian. I grew up doing some snowboarding. I play a little bit of hockey, as some Canadians do. I went to school at Mcgill University. This is in Montreal, in Canada. Has anyone heard of McGill or Montreal? How about Montreal? There we go. Awesome. Has anyone been there? Has anyone been to Canada? Yes, a lot. So you guys, sorry? You are a Canadian citizen. Amazing. So I think that I'm pretty good at building things and solving problems. I know that you've been talking a little bit about what you're good at, what you like to do, what you would like to do in the future. And so I also make it a big point to always make sure I'm learning. I'm always asking questions. I'm always trying to figure out how things work. I never just kind of look at something and say, oh, that's cool. All right, we walk away. And what was under there? How did that come to be? So this happened a lot when I was young. A good example of this is I'd go to a movie theater with my friends for birthday parties, things like this. We'd sit down, and I was never looking forward. I was never looking at the screen. And everyone else was all excited for the movie to start, but I'm kind of looking up, as I did actually right here. I'm like looking at the lights. How are the lights working? What's shining on me? Where are the speakers? How is the sound working? You know, the beginning of the movie, the sound kind of comes on, and the volume comes up, and it gets you really excited. How does that really work? And really what I was trying to look for is this guy who's sitting in the back of the theater with the projector, and these projectors that do these really cool things that shine these really bright, fancy movies on the screen. So this was always something I was really, really interested in. From there, I'll kind of fast forward. I went to school in Montreal, as I just said, at McGill. I really liked technology, and I liked computers, but I thought that I also really liked biology and chemistry and like how the body worked, how life sciences worked, how things happened when you ate, when you went for a run, when you did these things, when you played lots of games. So I started off in biology, and after a year or two, I discovered that it was really, really cool, but it wasn't exactly what I was looking for. It was more around how is the world today, how do these things interact, how do things work, and it was less about how do we kind of build things and how can we be creative? Can we make things happen? Can we put little different things together? So back to computer science it was, where I started to learn about computers, learn how to build them, learn how to code them, learn how to make them do what I wanted them to do. Sometimes they don't do what you want them to do, but then you have to fix it all up. So I worked hard there with a bunch of my colleagues at school, and I graduated. So I got my degree. So what do we do now? I have a computer science degree. I like computers. I like technology. So let's go get a job. Let's do some cool stuff out in the industry. Maybe let's get paid for it. That's always nice. So I started to do some interviews. I interviewed at a few big places, at some banks, big companies. I had to wear a suit and a tie a couple times to an interview. That wasn't too exciting, but I thought, hey, this is the right thing to be doing. I need to get a cool job. So I interviewed at this one big bank, and I thought it was going to be a great opportunity. I interviewed. I'd write these tests sometimes they make you take. I sat down with the hiring manager, and she said, hey, you did really good. You did really well. We think you'd be a good person to work with us. You did really well on your tests, but I don't think you should have a job here. And I sat there and tried not to look really disappointed because this was going to be my first job, and I was trying to be excited. And I said, oh, well, that's too bad. Why not? And she said, well, I don't think you'll find this work very interesting. We're a bank. We make some rich people even richer. And that's kind of what we do here. And it's the really nitty-gritty in the weeds of the mathematics and stuff. And you seem like you would be much more interested in things like video games and things like front-end designs where you're really interacting with the user. So I'm sitting here trying to get my first job and hearing someone who works for a company kind of say something negative about that company they work for. And I was like, wow, this is not what I was expecting, but this is actually really, really good advice. So I'm thinking, hey, wow, video games. That's pretty cool. Who here likes to play some video games? Yeah, I see a few hands. Wouldn't it be cool to make video games? You could You can make them do what you want. You could change how you interact with them. Big fan of playing some Madden, Star Wars games. I like the NHL games, all that sort of stuff. So I was thinking, this is a great lead. So this person gave me some contacts. I spoke with some companies. I had some more interviews, and I was getting even more excited. So this company interviewed me and said, we are making games for cell phones. I was like, oh, wow, that's actually kind of cool, too. This was about 10 plus years ago when cell phones were not exactly how you picture them today. Does anyone have one of these at home? I see some hands around the back of the room. Oh, I see some here. So these phones are a little bit older. You can see as they progressed, the screens got a little bit bigger, but there's, and everything has buttons on it. Those screens, believe it or not, cannot be touched. You can't do anything when you hit them. You can try a lot, but nothing will happen. And you can see the screens are really small. So I was like, okay, this is going to be a challenge. But that's kind of interesting because we started to work for some of these really big-named movie companies. And anyone heard of the movie Cars here? A few hands. It's a few years old. How about Pirates of the Caribbean? Yes. And then how about Happy Feet? Anyone remember Happy Feet, the penguins? Yeah. So there we go. They're pretty cute. We got this deal to make the video game for Happy Feet and for Cars. So on these really little phones, we wanted to make this really cool game that's fun for people, which had really never been done before. So I got the job. My manager told me to show up on day one to a new office, and it was about 10, 15 people. So I showed up, and this is what I saw. I was like, wow, this is the working world. There's nothing here. I thought I would get a desk. I thought I would have a lamp. I thought I would have maybe a pen sitting there along with my computer. But no, it was this. And literally, to the other side of the room were cardboard boxes with computers. And everyone was like, all right, go put your computer together. And I was like, oh, this is kind of fun, because I like to build computers. So I started to build things, and it was interesting because other people I was working with who had gone through computer science degrees didn't know as much about building the computer itself, the physical computer, and knew more just about how to code it. So we were all kind of teaching each other. We had all had these different skills, and so we put our computers together, we put our desks together, we put the legs on the desks, we put our chairs together. And I was like, oh wow, so I'm gonna come to this place every day and work and just hang out with these people and do some cool stuff. This is a lot better than wearing a suit and tie, I think. What do you guys think? Better? Worse? Yeah? Yeah, ties are kind of stuffy. So, as I said, we got some deals with these cool movies. I was like, wow, this is a group of 10 or 15 people, and we got a deal. This big movie industry is trusting us to make their game globally, to send it out, everybody can play it. That's a pretty cool concept. So we started to build it, both for Cars, Happy Feet, Pirates of the Caribbean, and we were just about to launch it. And then something really interesting happened, where they said, well, your game is looking pretty good, but by the way, we need to send it out, distribute it to all these cell phones, and the maximum size of the game in file size can be 1 megabyte. And we were like, wait, what? Like 1 megabyte? They're like, well, the phones only have so much storage. I forget exactly how much. But there was a restriction. And so you can imagine there's images in there, there's sound in there, there's the logic. Does anyone know, like on average, how much, if you take a picture with your cell phone, how big is that? Does anyone know? Yeah. It's 300 to 400 kilobytes. That's true. It could be even higher. So with all the fancy cameras, that's probably an average on a phone from a little bit ago. But these days, I would say 3, 4 megabytes. Does anyone know kind of how much like one music file would be? Someone else? Yeah? 10 megabytes. That's a good number. So 10 megabytes for one music file. So think about an entire game on a phone with images, music. We're like, wow, this is bad because it is not 1 megabyte. So we all went back. We're like, all right, we'll get it, no problem. We went back and we figured it out. And we took a lot of shortcuts and we compressed things and we figured out how the logic could work much better. And it was a really interesting problem to solve. So after working on phones a lot, making things on the phone work with games and interacting with the phone and the people, we're like, well, there's more. There's more to this. This phone does more than just plays games on it, right? I can talk to people. I can send text messages. I can take pictures. So why is everything on this phone only on this phone, right? That seems kind of problematic. So today, I mean, you all send text. You all use phones, potentially. You use tablets. and you have pictures, and the pictures can be sent, but none of that really existed. You couldn't send a link to someone. There was no browser. There was no way to back things up. There was no way to say, hey, what's my friend's phone number? And if it was saved on that phone or on your computer, they would not talk to each other. So I'm like, well, maybe we can make this happen for the very first time. So I went to a different company, and we figured out how to make a phone, take a picture, back it up to the internet. And that might not, no one's like wooing and eyeing, and I don't really know why, but that was really, really cool. So that was the first time that we had ever done that. This was, I don't know, 10, 12 years ago, and these old phones just would not transmit data like that. So we did that. Your telephone company, whether it was Comcast, you would load up Comcast.com, and you would see your picture. So that was the next step. So I just kept going. I'm like, well, I can transmit a picture, but there's more behind this. What's happening? What's behind all of this? There's more to it. So naturally, I was like, well, Google does more, right? They have a search engine, and they do even more than that. So how does all of this work? I applied for a Google job. I didn't get it. I was sad. I went back to my job, did even more work, went to a different company, did some cool stuff. I applied again, and I got the job. And I was pretty excited to kind of build on what I had already known. So quickly, we'll get into kind of the nuts and bolts, which I think are pretty interesting. But I had a bit of a role change. So as I had started my career, I started just coding. I did a computer science degree. I did a lot of coding to make things happen. It was really awesome. I really liked to understand how everything worked. I was starting to realize that I liked to talk to people also, interact with people, figure out what their problems are, what they needed, their things to do. And so I changed roles slightly to what we call a product manager. Some people think it's a freaking awesome job. I do too. But the really cool thing about a product manager is you are still really technical. So I still code almost every day, a little bit. I work with engineers, but I'm not a full-time engineer. So you have to really straddle the line. Does anyone know what a few parts of a product manager job would be? Any ideas? Yeah. Manages the products. So what about the products would they manage? Do you think? Make sure they're good for the public? Yeah, that's perfect. That's a good. So why don't, before I move on, if I talk about a product, let's talk about what a product really is. So what would you say a product is? Do you use a tablet or a computer? A computer. Okay, what kind of computer? An Apple computer? Perfect. So an Apple computer is a product. There's a product manager that is in charge of that product. So they're saying, what is the next Apple computer that we want to make? What is the next Apple computer that we'll release? You know, they release a new one every year. Someone is sitting there saying, we need to make this better. We need to make this different. We need to understand what you find frustrating. Does anyone ever have frustrations with computers? Yeah? Are there any? Yeah? Yeah, I think you're right. I get frustrated every day. So every time you're frustrated, we know about it, and we are also frustrated because we wish that we could release a product that no one would ever get frustrated with, which is almost impossible, but we try really hard. Anything else that someone thinks a product manager would do? I saw a hand. Did you have your hand up? Yeah. Checks if it's working, yes. So we need to make sure it's working properly. We need to make sure the users are going to use it properly. We need to make sure the engineers are doing the right work. So essentially, a product manager does everything. So if anything needs to be done, and I've gone to get my engineers coffee before, I've gone to get donuts, I've sat there to make sure their code and their text is correct, everything and anything. And that's why it's a pretty fun job, because at the end of the day, it all comes together, and it's up to you. So let's move into Google a little bit. So Google is a search engine, right? You can type stuff in, you get feedback you get results on what you're looking for. But what else does Google do? Yeah. Google Docs, Google Drive, right? You can write documents, you can share them with people, you can do spreadsheets, yeah. Yeah. The drawings, the doodles, right? Like on the homepage, as the logo changes. Yeah, we have doodles that are very kind of, they're fun, they're cute, they're informative, and things like that. Yeah, definitely. Yeah. Google Maps, good one. So how to look at the maps of the world, navigate, all that sort of stuff. Chrome, yeah, perfect. Sorry? Google Glass, yeah, we're making physical products, yeah. Sorry? Images, yes, so you can do searches and get searches back. I'll take a couple more. And Google Earth, right, so a type of maps. So many. You guys even know more than I do, and I work there. This is strange. Yeah. Self-driving cars, right. So let's think about self-driving cars for a second. So there's a lot behind self-driving cars that make a car work, right? Do you think, what other product does somebody just say that self-driving cars need to work? Yeah. A map, exactly. So how does the car drive without having a map? This is perfect. What about if a car is going down the road and it sees a strange object, and let's say it's a dog, and Google needs to know how that dog is going to behave. If the dog is big and small, it can do a search and find out the size and how quickly it's going to move, things like that. Yes? Okay, so as you all know, Google does a lot. You said a lot of things that are not on here, and there's a couple things on here that are a bit old, and Google kind of keeps coming up with new stuff all the time. So there's so much under the hood at Google. So how do you think all of this works? When you go to google.com or to maps.google.com or to drive.google.com and you hit enter, what happens? Or when you go to Gmail and your email is stored on this magical server. So where do you think that email is being stored? Does anybody know or have an idea? Yeah. On your files, right? Okay, where are your files? Yeah. In the cloud. Good answer. The Google Cloud. So there's a really funny April Fool's joke actually from last year. If you go later and look at Google Cloud April Fool's, that the cloud is an actual cloud. And we're going to take your actual data, we're going to throw it up there in the sky, and then anyone else can pull it down. And that's how the cloud works, right? So what is an actual cloud? Can someone have an idea what does that mean, the Google Cloud? Yeah? Yeah, so all your data is stored up there. When you want it, you can get it. That's exactly the idea. Yeah. Google Cloud stores data. Yep, it's. Yeah, I like that a lot. So a cloud stores water. When it rains, you get it back, so that your data goes into the cloud. When you need it, you can ask for it. It comes back down for you. So this is great. So when you have files at home on your computer, right? Where are those files stored? Does anyone know? Yeah, your hard drive, right. So when we start thinking about what is the actual cloud is just a computer, right? It's a computer, it stores your data on a hard drive, right? This is just kind of it's also too, who has a computer that looks like that at home? Oh, all right, still a bunch, probably more people around the back again. The desktops have shrunk a bit these days, but the cloud is really just a computer and a hard drive, and that's where your data is. But how many people are in this room? Maybe 40, 60, 70 people? So it would take a bunch of computers probably to store all your data. We need to support millions and billions of people. So how do we do this? We take a server, which a server has more data storage, it has more computing power to do all this cool stuff, and we make them look different. We take the screens away, we don't need them, right? Because you use your screen at home. So this is probably good for another 10,000 people or so, and it goes in the cloud. But we need even more of that. We need to support 1 billion people. So we take a bunch of servers, and we stack them, and we put them in a rack, just like a bookshelf at home. So now we have a bookshelf of computers. Is that enough? What do you think? Is that enough for 1 billion people? No, probably not. So now we have a data center. A data center has many, many, many racks of many, many servers, all shoved together and in one big building. So do you think one data center is enough? No, probably not. So I would love to click the next slide and show you all the data centers, but I don't even know where all they are. So Google has about 7 or 8 data centers around the world. We're growing by about 10 or 15 in the next year or two. And so this is what we call the cloud. We call the cloud all these computers on these racks in big buildings, and they all talk to each other. We like to make copies of them, so if one of them has a fire and gets damaged, all the data is in a different data center. So this is really what we talk about when we talk about the cloud. There's some more cool pictures online. And so what I work with is these Google data centers. and all of this infrastructure. So really, there would not be an iPhone, there would not be a Google self-driving car, there would not be your Gmail. Anything that you do these days has to have a computer behind it, right? And the computer behind it is our cloud. So how, an interesting problem that comes up with these data centers a lot that we've had to figure out, which has been really fun to solve, is what happens if anyone has been sitting with a laptop at home, with a laptop on their lap for maybe an hour or two, maybe you're watching a video. What happens after a little bit? Who haven't I heard from? Yes. It gets hot, right. And wow, and it gets kind of uncomfortable. You think, maybe this thing is gonna melt. I've heard about these things going on fire. That's pretty bad. I don't want to catch my house on fire. So you kind of put it away. So think about thousands and millions of computers in one building. What do you think could happen to all of that? It'd get really, really hot. So back in the day when these data centers kind of were a new thing, what they would do is they would get air conditioners and put like 5,000 air conditioners in one big building. And that seemed like a good idea. Because it's hot, we got to make it cold. That's a good idea. But what do you think the problem is with that? Any idea? Yeah. Cost, for sure. It's really expensive, isn't it, to run an air conditioner? I know when it's hot here, which is not that often in the Bay Area, we run our air conditioner, the bill goes way up. Anything else that anyone can think of relating to cost even? Yeah. It takes a lot of power. That's right. So we're consuming a lot of power for each air conditioner, for each building, and this is kind of inefficient. It's taking a lot of resources, and it's just not very good for the environment. So what's another way? If you have something really hot at home, maybe a bowl of soup, it's way too hot to eat, and you want to eat it right now. What would you do to cool it down? Anyone have an idea? Yeah. Put an ice cube in it. That's a great idea. Yes? Sorry? Put it in the freezer. That's another great idea. So you guys should have been working for us, because we didn't come up with this for a long time, actually. It took a bunch of years. So instead of taking all these air conditioners, putting them in, and running them, we're like, well, why don't we build data centers in places where there's really cold stuff? And we can just cool the data centers off with ice and with glacier water. And so that's what we did. And so now a lot of these data centers use cold water, and they cool the data center. They take the hot air out. They put the cold air in from the water. And there's zero cost by air conditioners. There's no hurt to the environment. And so this was kind of a fun problem. This is a picture of inside a data center where the cooling systems are. And they paint all the different tubes to know where they're going and where they're coming from. So these are massive, massive systems. But these are like 5 of us sitting in a room saying, hey, you think we can cool this with cold water? And someone saying, that sounds like a cool idea. Well, let's draw up a design and do it for one room, and then say, hey, let's do it for a massive building. And then your project of the 5 of you becomes a reality. And that's really how things work at a lot of these companies and at Google, and that's why it's a pretty fun place to work. So what does this all kind of mean for the cloud and for you guys who are learning how to code? You're learning about technology, and hopefully that you get excited about it and want to make it a career or get a job. You could get a job in a bank. Some people find that very interesting. I kind of like the infrastructure stuff. So again, without any of this infrastructure, none of these devices would work. Has anyone kind of heard of the phrase, the Internet of Things, lately? It's this new phrase coming up around everything you have being connected to the internet. So your thermostat at home that changes the temperature, your stove, your lights, your microwave, everything we can control with the internet. Well, all these devices have to connect to something. They have to be secure. They have to work all the time. You can imagine if you go home and your lights just never turn on because there's a bug. That's bad. People will be angry. They'll probably yell at me, and that's frustrating. So what we try to do is we try to take all this cool stuff in the cloud and make it so that you can build stuff on it. So we give you a toolbox, essentially. So today you were building on the Raspberry Pis. So what were you trying to do on the Pis? Yeah? Yeah, you're trying to make a light work. So that's exactly like making a light work in your home, right? If you can do it on a little Raspberry Pi with a few lines of code and a light is attached to it, you can make your lights in your house come on, right? There's really not much of a difference there. So we give you the tools to do that on the Google Cloud. You could literally take the code that you wrote today you could go to our cloud system, and you could put it on one of the servers in the cloud, and it would run for you. And I'll give you a couple links, and you can try that later yourself. So really, this all means we want a way for you to bring your ideas to life. All the ideas that you've done here with your Raspberry Pi, anything that you see out there, anything that you have questions about, any device that you want to build, we want you to run it on the Google Cloud so that it just works. It would work for 50 people in this room. It would work for 5 billion people all at the exact same time. And we think that's pretty cool. I think that's pretty cool. And that's what I keep trying to work on. Has anyone heard of Spotify? Yes. Anyone use Spotify a lot? Yes. So Spotify runs entirely on the Google Cloud platform. So they work on the Google infrastructure. When you type anything into your search engine and you hit go, it's the same computers running your search results as run Spotify. Does anyone know who that is? Yeah. I'm a latecomer. I think I just installed it last week. But another user of Google's network, what about them? Not always the healthiest, but they do a lot of cool stuff. They do a lot of good marketing campaigns. And this, again, they run on our network. Another one, we've heard of these people, right? So the cool thing is all these companies come to us and they say, hey, we don't want to buy servers. We want to use your servers. You're Google, you're great. You have fast servers. And so we're just like, that's awesome. Come use our servers, pay us a little bit, and then you're good to go. So that might sound really big. Snapchat is a very big application. Spotify is a very, very big application. You're like, wow, that's a big company. But the really cool thing is you could take your application that you wrote to turn a light on, and you could use it on Google's network, and you can make your lights come on in your house. And we have some kind of tutorials that we can pass around and link you to help you do that. So that's kind of what I wanted to talk to you guys about. What I always would recommend, and from all the answers, it sounds like you kind of get it. You understand the concepts here, and hopefully you find this pretty interesting. I would hope that you would always keep asking questions. When you see something work, when you see a light come on somewhere, you're like, how did that light come on? Like, did that come on because I walked in the room and there was a sensor? Oh, there was a sensor on the wall. What was that sensor attached to? Right? What did that talk to get that light to come on? There's always a connection. And it's always really good to think about these things and try to understand, what is that connection? How did that happen? Can we do more with that? And so looking under the hood is something that I've always had maybe a bit of an obsession for, and always trying to figure out how these things work. Being creative to make it new and fancy and do things that haven't been done before. And then here's just our link. You can go to cloud.google.com, learn more about it. And that's pretty much it. Does anyone have any questions? Questions about anything that I have said?
Yep.
Yes.
How did you go from the video game industry to being a product manager?
That's a good question. So when I was in the video game industry, I was pretty much full-time coder. I just coded every day, all day. I had product managers kind of like help me with what I should be doing every day. And I started to work more with the product managers and wanted to be involved in their decisions. And so they were happy to invite me. So I'd sit in these meetings and I'd listen to people talk about why we should do this way, this thing that way, this way or that way. And I started to have feedback and give them feedback. And they were very kind of receptive of it. So I just kind of had a lot of interest in it. And I started to volunteer my time to work in a different role while I was still doing my main role. And they really appreciated that and said, you know what, you have a knack for this. So sometimes it's hard to do a different job that you haven't been doing yet. And people they trust you doing what you've been doing before, but they don't really trust what you haven't done because why should they? They don't know if you'll be good at it or not. So a lot of that is just about being proactive and kind of volunteering your time and showing that you're excited and that you think you can do what they're doing very well, and they'll include you. Does that make sense? Cool. Yes.
What age were you when you started getting interested in coding and technology?
That is a good question. So I think my first computer came home when I was I don't know, I'm gonna look to the back where I might actually have some family members in the room. But 10 years old? 8 years old. I was probably 8 or 10 years old when the first computer came into the house. And we poked around at it, we all sat in front of it, and we stared at the screen and waited for something to happen, and nothing did, and then we typed a few things. So it was quite early. I started playing some video games and wondering, how can I change these? How can I make them different? So it was pretty early on, probably in my early teens, mid-teens, when I started to really start doing some coding. I have colleagues at Google who are full-time software engineers. They didn't code until they were 20, 25 years old, and some of them did when they were 6 or 7. So there's really nothing stopping you from starting a little later or earlier.
When's Google Fiber coming to the Bay Area?
That is a good question that I unfortunately don't have the answer to. But I would hope really, really soon, because I would really like to have it.
What's your favorite video game?
Favorite video game? So unfortunately, because I work too much these days and I like the work that I do, I don't play games as much as I would like. But I would say NHL, what year is it now? NHL 15 has been my favorite of the last little while.
You said you liked hockey, right?
Yes.
So were you in any competitive league?
I was not, unfortunately. So I grew up in Toronto, in Canada. Everybody plays hockey. I played a lot of hockey. I probably played up to my high school level. And I still play here every week with a bunch of guys in San Francisco. There's a bunch of hockey leagues for men and women. And I don't score many goals, but I like it a lot. Yeah? Anyone else? Yes.
What do you like to do in your free time?
Good question, too. So I like to strike a balance. I like to play hockey once a week, as I said. I like to go biking a bunch. I do a bunch of road biking. I was hopefully going to go this afternoon, but the rain, I don't think is going to stop. I like to do that, and I also like to tinker with computers. So we have a lot of computers at home, laying all over the place, which I sometimes get in trouble for, but I just like to play and tinker around and buy gadgets and play with technology. And I like to also try to merge technology and the outdoors, because I like both things a lot. So tracking your activities, figuring out if I did better this time or better last time, and why, and stuff like that.
I have a question about Google. So does Google have any like a backup, a backup place for the data center just in case something happened?
Yeah, very good question. And I think every single one of our customers asks us that same question, because it's a very big problem, right? What if there's an earthquake somewhere? What if there's a fire? What if one of these pipes carrying all this cold water breaks open and it splashes all the computers and they all break? So yes, so every single piece of data that you store on Google is duplicated or replicated probably 3 or 4 times. We have some different types of storage that are easier to get to and harder to get to. Like we have, you could put data on a tape, like your old tape cassette or a VHS tape. Who remembers a VHS tape that you put into a or even a cassette tape? You've seen cassette tapes? So those tapes can hold data as well. And so we save things on those tapes, and we store them away. So there's always a copy. There's many data centers. And so unless all the data centers have a problem at the same time, we're in good shape. Yes?
How do you spend your money?
How do I spend my money? That is also a good question. Probably not as well as I should. I buy a lot of gadgets. I like toys. I buy bikes. I buy electronics to put on my bikes. I buy electronics to put in my house. I like to go traveling, though. So I spend my money on traveling cool places and meeting people and exploring and things like that. So many ways. I also like to eat different kinds of food. Yeah.
Do you guys work with robotics?
So I don't personally, but the robotics teams do work with our infrastructure. So this is every single team at Google works with my team because they need somewhere to put all their stuff and to make all their systems work. The robots too, right? There's no wires, right? There's no wire connecting the robot to a computer because otherwise how would they walk around the room? So they need to talk to something. What do they talk to? They talk to the cloud. And so my team doesn't personally my team doesn't, but there are teams within our infrastructure team that work with the robotics. Yes?
How long do you keep deleted information?
Sorry, how long do we?
How long do you keep deleted information?
Good question. So we have a pretty company-wide policy. If you tell us to delete something, we delete it within 30 days, and entirely, which sometimes gets us in trouble because you come back, you're like, oh, wait, I didn't want to delete that. I really need it. We say, we're really sorry. We have to listen to your wishes. So we delete everything within 30 days of you asking us to delete it.
Do you have a favorite animal?
Also a good question. So I have a pet cat at home. I like cats. I do like dogs also, but unfortunately I'm not home enough to have my own dog. But I'll go with cats. I'm a pretty big cat lover at the moment.
What are your views on a predicted post-singularity age where basically AI overtakes humans?
So that's a very good question, and I'll give you a short answer, and I can talk about it with you more later. But the thing with AI is that it still does what humans tell it to do. You're still programming it to do a certain task. You're making it smart so that it can figure out how to do that task if it has an obstacle, right? For example, a car, or I'm walking down the street, if I'm a robot, there's a log in my way. I can't get over it. So if I tell it to be smart, I don't program the robot to say, step over the log that's in the street. I say, there's something in your way. What are the options for you to get around it? So as much as computers are going to be smarter and intelligence is going to improve on computers, there's really no connection right now that we know of in terms of like movies, like a Terminator movie, to something becoming to the point that it can do things that we haven't told it to do. So I'm not worried about it, but who knows what could happen.
What's your average workday like? Like, how long do you work per day? And
My average workday. So that varies quite a bit. I'd say I'm usually in the office by 9:30. Depends on if I have early meetings or not. We work a lot with people from around the world. So I work with people in London, in Poland, in Sydney, Australia. So sometimes I have to come in early, like at 8 or 8:30 or 7:30 to meet with them because they're even at the office late. But typically I'm in by 9:30, and I try to get out by 5 or 6. But Google is a very flexible environment. If you have an appointment in the afternoon, you don't have to clear it with 10 people and get approval. You just say, hey guys, I'm going, you go. And then if you have to catch up on your work, you catch up on your work. So it's a nice place to go.
What would be your favorite part about working at Google?
My favorite part, besides the food, I guess. My favorite part really is the people, I think. The people are really fun to work with. Everyone is very open. Everyone is very supportive. You can have really good discussions with people who disagree on things, and nothing is really taken personally, right? You give someone your opinion, they give you their opinion, you talk about it, and you usually come to a resolution. So instead of some places where there's a bit more aggressiveness, I find that doesn't really happen at Google. So I really like the people.
Have you ever traveled in the Google self-driving car?
I have, actually. I have, thanks to the Computer History Museum, as there is a self-driving car in the museum, if you've seen it, downstairs. So when the car was here, when it was brought in, I think for the first time, the team said, hey, we'll give all the museum staff a free ride. I had some people I knew here. I gave them a call, and I really quickly got on a Google bike. I biked over, and I got in the car. So it was pretty fun.
Are you making something like Siri or like Alexa and Google?
Oh, so Alexa is the Amazon product, right, where you can talk to it? That's a good question. I don't actually know. It's a pretty cool thing. It's a device that you can speak to, and it will kind of respond to you and play music. So I'm not sure.
Why do you want to work at Google?
After all this, you don't understand? Can't get it? That's a good question. Any other reasons besides the people, the food, the flexible work hours? I think also, like things that I talked about, just kind of getting things done. So you can actually take an idea. So I wasn't really exaggerating when I talked about an idea to cool the data centers. If you have a cool idea and you write up a proposal and you get people to look at it and say, yeah, that's a good idea, you can do that. And give you people to work on it. They'll give you money to work on it. And that's pretty amazing because you can do some really, really large-scale things with an idea that you had, when you woke up in the middle of the night and be like, wow, I have an awesome idea to improve Google Maps. Go tell the Google Maps people, and it could be reality. So that's pretty fun. Yes?
What are your views on AlphaGo?
Views on Alphabet? Like as the company?
No, like in Lisadol, like the AlphaGo intelligence again.
Oh, the AlphaGo. Good question. So who knows about AlphaGo? Have you heard about this? A few people. So AlphaGo is an artificial intelligence piece of software to play the game Go. Is anyone who knows about the game Go? So it's an old Chinese game with just black and white pieces on a big grid. It has a lot more possible choices to move than chess, which is also a very difficult game. And Google has just designed a piece of software called AlphaGo that beat the best Go player in the world. Sorry? A 9-den rating, which is a very, very high rating. And that was seen as being very, very impressive because there are so many possible moves that a computer has to go through every single move. And it was deemed to not be possible for about another 10 years. So I think that that's pretty awesome. I think it's amazing. The team had an interesting idea how they could do this, and went and they coded it up, and they tried it, and it worked. And so the software that powers that, actually, it's called our machine learning software. It's available on our Google Cloud platform for you to use. If you want to try to train a computer to know when to turn a light on in your house, you can use the same powerful backend as the AlphaGo machine to do that. And so it can see, oh, are you home? Are you not home? Are you coming home? All that sort of stuff. So it's pretty cool. I think, oh, yes.
So you said you like to put technology on your bicycle.
Yes.
Since you work at Google, is there some kind of crazy cool technology, kind of like what was on the Behemoth, but current generation?
That's a good question. Not that I know of, unfortunately, because I would go work on that team. I find it's a really big problem. Yeah, I'll vent for about 30 seconds here. I have a light on my bike. I have my little computer that tells me how far I've gone. It has a GPS in it. I have a backlight, right? I have all these things. I have my phone in my back pocket. And everything has its own battery. Everything works on its own. Nothing talks to each other. And this is crazy in our world of technology. So also working in infrastructure at Google on the cloud, we should be able to make all these things work together. But it's really, really hard. And so that's a problem that we're working on today. Yes?
You talked about Africa. You just came from Africa? I'm from Africa. But I was wondering, did you go to Africa to have fun, or you went to,
Yeah, so I went on a vacation last summer for about 2.5 weeks, to Namibia and Zimbabwe for fun. Purely for fun. I have a friend who is an engineer there, and so we went to visit him, and he showed us around, and it was awesome. It was incredibly friendly people, really cool landscapes, cool technology in certain places that you wouldn't expect, different than here, and again, a really, really great reason to travel and to see how different people use technology in different ways.
Great. Do we have any last questions from anybody? No? All right. Well, I have a last question for you. You've shared a lot about your personal story and the technology you use, and I think the students have shared a lot with you about their own knowledge and passion. So as all these amazing students are going off towards their futures and they're getting excited about technology and their own abilities to solve problems and take on challenges, what advice would you give them as they're going off into the world and towards high school and hopefully college and all kinds of other adventures?
Yeah. Great question. So, I've talked a little bit about always asking questions, always kind of looking under the hood. There's all these really, really cool platforms out there online to teach you things, geared at all ages, younger than you and older than you and yourselves. But really find something that you find really interesting. And, people will say, oh, go find an area that you like. Like, really like cars, go work with cars. You really like airplanes, go work with airplanes. You really like the food service, That's great, but you might not know what you want to work with, right? You might not say, oh, I love cars or I love this more than anything else out there. So really, my advice there, and that's kind of where I came from, is really just to kind of always keep your eyes open and always keep asking questions. And kind of what you really like to do will come to you. Infrastructure, if someone had pitched that to me when I was really young, would have been like, well, that's a long word. That sounds kind of boring. Not very cool. But when I looked at it and said, oh, wow, how do these things all work together? You mean we're going to be able to build 10 or 15 enormous buildings around the world with wires connecting them and thousands of computers inside of them. That sounds pretty awesome and exciting to me. So just keeping your eyes open and don't underestimate what is involved in making something work.